Hey guys, this is Alex Pierce from LightsailVR.com. In this video, we're going to be talking about the Kino Flo Mimik, which is a new image-based lighting system. I visited Kino Flo recently and I interviewed their founder and engineering manager who will tell you all about the technical specs, but first I want to give you some of my own opinions. What I'm about to say is a very bold statement. I think the Mimik is the most exciting technology we have ever seen in virtual production. We have seen a lot of advancements in LED screen technology, LED processing technology, game engines, and camera tracking, but nothing is as important as great lighting. Lighting is the reason I can even shoot this interview on an iPhone and make it look cinematic. The quality and the color of light is very important. I could shoot this on a different camera and this lighting would still not look great. The Mimik will become the industry standard for image-based lighting, and you'll want to use it for LED volumes as well as green screen workflows. I know many people in this community don't consider green screen virtual production, but if we look at ILM as the standard for virtual production, they still shoot a majority of their shots on green screen or blue screen. With the Mimik, even if you're shooting on green screen or blue screen, you still get a lot of the benefits from LED wall production. You can have interactive lighting that plays on the reflections of your character or your cars or your water. Even with just one panel and one processor, you're going to be able to do things that you just could not do before. I'll let Frieder tell you all about the Kino Flo Mimik, but I just wanted to say that I think this light is incredible. I think it's a game changer, and I don't use that word ever. I really think it's going to be a very, very big deal for the virtual production industry. So if you don't know about the Kino Flo Mimik, pay attention. All right, let's jump in.
Hi there, I'm Frieder Hochheim, founder of Kino Flo Lighting Systems. We're here at Kino Flo, and we're looking at the Mimik image-based lighting system. Now, it's a lighting tile. I say tile because it's very much like a video wall, and it's designed to link together. It consists of 7,200 pixels. Now, a pixel on a video wall is RGB, 3 pixels. And so what we've done is we've taken 3 pixels RGB and turned them into 5 pixels. So we're adding a 2700 Kelvin white and a 6500 Kelvin white. And the idea is that when you blend all this together, now we're fleshing out the spectrum and we're giving a full spectrum reproduction. So very much like you're on location and you've got like a midday sun like we have over here, and that's what's lighting your subject. Over here, we're now taking that light quality, transferring that to the Mimik, and now projecting that onto the foreground subject. So if you're simply trying to photograph or trying to light with an RGB light panel, you're not getting the full color reproduction of the wardrobe, of the skin tones and whatnot. So it's been really important to try to render that image as a full spectrum image, essentially a light source now. Now, normally a video wall runs around between 800 and 1200 nits. The Mimik panel runs at 400 watts. It's capable of generating upwards of 10,000 nits. Now, for those who don't know what a nit is, 8,000 nits is approximately what the midday sky emanates. So that's a fair amount of light, and considering how fast the cameras are nowadays, I think it provides a fair amount of really substantial light for that foreground. The other thing that's very important here is we are interfacing, obviously, with screens, with cameras. We're looking for a lot of flexibility and effects. So we have a refresh rate of 30 kilohertz. This allows us to shoot up to 960 frames a second. This also opens up the whole notion of alpha channels, where you have a frame that can be subdivided into subframes. It's known as ghost frame if you're on a row panel, but we can interface with all of these types of systems and provide that kind of technology. Now, the main thing to understand here, this operates off the megapixel Helios processor. This doesn't mean that we can't operate on a set that is Brompton run or Novastar. So we're actually screen agnostic. We run parallel to any of those systems. So if you're on a Brompton set, we simply apply the Helios processor as a parallel. We'll pull the same video signal, run it through the Helios, and now we can actually genlock the light source to the volume. Now, how is this system different from DMX? Why can't this be run DMX? Well, This panel is 7,200 pixels. That would be 140 universes. And this is just one panel, the panel size being about 2 foot by 4 foot or 600 by 1200 millimeters. So you can well imagine how many universes this would explode into if we were try to use DMX. The other issue with DMX, of course, is latency. Now, we're dealing with sometimes between a second to a second and a half in latency, so there's no way you can actually gen-lock the two. So where we are trying to synchronize exactly the light to the volume or the action in the volume, the only way to do that is through the Helios processor, or by essentially avoiding DMX and being able to then align that through a timing clock so that it all gen-locks together. So obviously the reason for using this kind of lighting is the fact that it's reflecting the world around the subject of that scene. There are different ways of working this because you don't actually want to photograph this screen. And because it's a 10 millimeter pitch, it's rather low resolution. So when it comes to reflective subjects, now the challenge is at what distance are you from that reflective subject? Is it going to pick up the pixels? If it picks up the pixels, we are in the process of designing a yoke right now that will accommodate a diffusion material. Now that diffusion material is very unique. It only rides about 3/4 of an inch off the screen, enough to take out the pixels, but maintain let's say, a very soft image that's still very dynamic, without huge drop in, well, it's maybe about a 3/4 drop in light level. So that's one way to work around reflections. The other thing is, especially if you're doing vehicles and whatnot, that you have windshields that are reflecting the sky, you can still use other panels to catch that reflection, but you're using the Mimik to drive the light into the car, into the interior, and actually illuminating what's important, which is wardrobe, skin tones, that kind of thing. So the two actually can harmonize very well together, where you're still working with RGB elements around the vehicle, and you have to remember, as a reflection, they're not going to be as bright as what we're driving into onto the set, onto your subject. That's where this really comes into play, the fact that this is a light source. If you do need to see a reflection, there's ways of dealing with it. So all the mapping takes place in the Helios processor. We don't need secondary software in order to map this. You don't need MadMap or anything like that. It all happens within the Helios processor. Now, what's been really important to lighting technicians and to filmmakers in general is who takes control of the light. If it's a light source that's illuminating your foreground subject, normally that's a function of the lighting department. And it's all about accountability. Who's going to be responsible for the light settings on the set? So what we've been able to do through the Helios processor, we can actually now assign functionality to a lighting desk. So for instance, when it comes to light levels, you want to control light level, you want to control positioning. So what we do is we first bring the mimics into the Helios processor, we map them, and from there, once it's mapped, we can actually assign functionality such as shifting the mapping through XY. We can assign that to a desk. We can also assign the light levels, as well as even going into the color picker on the desk. Now, the beauty of this system is not just an image-based lighting system. It can also be a white light generator. So essentially, it can be a tunable white Kelvin source. So you can go into the color picker, change the colors on it, all the things that you normally would do with a on-set lighting fixture that is not image-based. You could do that off the desk. It does require the desk manufacturer to come on board and write the translation software to allow that functionality to be replicated on the board. But this is, I think, creatively, within the creative community, a very important step, that the lighting department maintains control over the system and also has the accountability to the director of photography when things need to be changed.
Hi, my name is Mark Primrose. I'm the engineering manager here at Kino Flo, and I'm basically project managing the Mimik. So this started out of a meeting at ASC and a presentation by Lux Machina about the problems with VR production. So we're excited to show you what the Mimik can do.
Yeah.
So the Helios is controlled from a web page. It doesn't require any special software to be installed. There's And it can be controlled from multiple users, and you can create a different login per user, giving each user different rights. So here I have the same screen. This is an Apple Mac Mini that's serving this web page. This is an Apple iPad. If I take my finger and drag the block, you can see it's being reflected on the Apple screen, and the content on the tile is changing appropriately. The other thing we've done to make it easier for lighting desk operators is CAMSYS, which is part of the Chauvet group of companies, has wrote software for the CAMSYS Magic Cube board that allows the Magic Cube to speak to the Helios over an open API, which is available on the Ethernet port with the REST protocol in JSON, which allows the same functionality. So I can take a block here and move it around, and you'll see this tile here, you'll see it remap. We also have the ability to change to white from here, as I showed earlier. So I can take the whole set to white. And we can also change colors. This is from this board here. So this is all functionality that could be added to any board. It's just the board manufacturer is going to have to choose to write the code to do it. This is an open API. It's nothing closed source, nothing unique to Magic Cube or Megapixel that prevents us from somebody else implementing it. This is over the Ethernet port, and we're both talking over a LAN switch. This is a different port than the data port that's actually going out to the LEDs. The other thing that's interesting that we've done is this particular Magic Cube Studio Connect offers timecode. The playback unit in this case is a Blackmagic HyperDeck, which is sending timecode out. The Studio Connect is receiving the timecode and could drive scenes, meaning we can change the position of the mapping per scene if that was something you needed to do. As we mentioned earlier, we're not licensed for Ghost Frame because we're not a row panel. It says literally right here, Ghost Frame not supported. This is what Megapixel calls camera mode. The Ghost Frame license is particular to this invert function down here, which if I try to click on it, it won't allow me. So that's the piece of the license that we don't have because we're not licensed for Ghost Frame. So what this allows us to do is these tiles support 16 slices on one and 9 slices on the other. And it allows us to go in per slice. This is a 60 frame per second video. The slices, these would be the sub slices in 60 frames per second. So you can see here in the first one I sent for video 1, which is the main video, I sent 2 of the slices to show that. The next one is a green and the next one is a magenta. By running these back to back, our human eye doesn't see this green screen because it's actually merging the two together. I'm repeating it to reduce the flicker. So if you look at the wall, you don't see much flicker. You're seeing the main video in the background. If I continue, we can bring the intensity down further so that you see even less of it. And then you would adjust the camera that's looking at that slice accordingly. So now you see mainly our main video coming through. Yes, so this is 1 frame worth of 60 frame per second video. So in a 60 frame per second video, we can have this many different things going on at a time. Per slice of the 60 frame per second, we can choose whether we want a video, we want to do a still, meaning we can actually store a picture in the tile and have the tile display that picture or display a second picture. And then we can put up some chroma keys as well as a black. I'll just switch one to black so you can see the black. So this would be, in this case, we'd show video for this slice, then we switch to black, then we switch to green, then we switch to magenta. Again, all the way across, this is 1 frame worth of 60 frame per second data. Yeah, so if you wanted a camera to actually see the green screen, you would set the second camera offset from the gen lock to this time, and then it would be the same across. So that's basically all we're doing. So in order to do this, you have to have a gen lock system with multiple outputs. We have an everts here that has 6 different outputs off the same time base, and then you can put an offset per output. So you could have multiple cameras all offset from the time base in order to look at a separate subslice.
The camera sees the full image quality, but when you're looking into the screen as a performer or whatnot, the image just goes down in contrast. but you don't really see flickering or anything, so it's very comfortable to work under.
So keeping the flicker down is by adding more of the video content in. So now I only have one slice that's actual video content. I'll put some more blacks in here. And you start seeing some jitter.
Yeah, and the camera sees it for sure.
Because I only have, out of those 16 slices, I only have one that's video slice.
Right.
You also notice that the actual light output has come down. Well, only 1/16 of the possible time is the video actually on, times the scan ratio. So now we're 16 times 3, so 1/48 of the time the camera's actually, the light's actually on. You see, because of the high frame rate, we're running out already 60 frames per second. Even with the sub slices, you really don't see that much flickering. And this is only because this panel can go 960 frames per second.
And again, none of these things would ever be achievable on the current image-based lighting systems that are DMX controlled. They can't do any of this.
Now, the ability to change what's on the light in time with the shutter on the camera is totally unique to this product. There's no other product that has that kind of sync capability where you can hard gen lock the light source to the camera. And in this case, Megapixel guarantees that the LEDs are actually emitting photons at that point in time. If I was to bring in an external sync here, I can put a sync delay in. So I can force an offset if, for example, the camera has a setup time and I want to skip some setup time before I actually put an image up, or if I want to do it beforehand, I can force another nanosecond accurate sync delay. So this is very unique to Megapixel and the Helios. Obviously, Ghost Frame is a patented subsystem. The Ghost Frame patent is related to the ability, if you have multiple videos coming in, to put up a negative of the video, so us as humans don't actually see it. The camera would see it, but you wouldn't see it.
Now we can run this as a ceiling. The 600 by 1200 millimeter footprint harmonizes with other systems that are of that same size. So if you already have an existing ceiling, you'll be able to drop out an existing one and replicate it with this. So in larger sets where you want to have that mood, that tonality from above, and you're seeing certain reflections of it, sometimes a combination of the two might work well. But again, every shot has its own unique challenges. And we think with this, you've got the most flexibility. This product is designed to link together just like a wall. You'll be able to fly it, link together. You'll be able to create a giant wall, or you can run it individually. Right now, we're only looking at it on a single yoke. We're also going to have a double yoke, so it'll be two of these panels stacked, and it'll have a snap-on diffusion frame. Once you get into larger setups, we have a diffusion material that we hope to bring to market. It's a type of frost. It's actually a little prismatic. It has very high translucency, transmission as well, but it rides much further off the face of the unit. So if we're going to do a larger panel, let's say you're going to fly something that's now 12 foot by whatever, 15 feet, 16 feet, now you can actually suspend a much larger material underneath all of that. And I haven't yet done it, so I'm really curious to see how that plays on reflections, because it'll be much more transmissive, but the actual pixels are not going to be as discernible. So again, we're exploring new ground with all of this.
Each of these mimics is actually two separate panels. That's the ability for us to actually do the split, where we have two separate images. There's two receiver cards there. There's only one external connection, but inside the tile itself, there's two receiver cards. And then there's actually 8 LDMs, or LED display modules, that are each individually removable for repair. But more than that, in the Helios itself, you can see that one flashing as I select it. And I can tune that particular submodule however I want to. I can make it more red, make it more green. I can reduce its intensity if I wanted to. So I've basically turned it off. So if there was something you wanted to mask out, or if you wanted to have like this particular set of LDMs set to dimmer, I can dim it and it's just dimmed. So I just dimmed the entire one behind him. So irregardless of what the video does now, these intensity variations or adjustments are going to remain through. It's going to do this on the fly. So this allows you to customize tile to tile for your particular shot. It's not intended to be unique rigging to Kino Flo. We're looking to add speed rail mount points so you could rig it to whatever you need to. And it will be usable with the ground support kit, with the rig bar, those type of typical LED walls stuff as well. And we also are going to build a rolling wall system as well. So we're excited about the possibilities. We're offering it on a yoke to make it easy to use a single one. And we're going to make a bigger yoke that is 2 panels high as well.
There's also one other way of looking at this, and I think this is where rental houses have been very curious as to how this could work outside of just a volume. Since it is a white light source, in certain situations you may want to use it as an image-based light. For instance, fire, certain effects. It may be just as easy to throw a video on there and then do that. So there's a simplified way of putting all this together, which would essentially be a playback unit or a computer, the Helios processor, and then the panels. So we're looking at other iterations of this product. This is just the first iteration. So we're looking at a whole family of products that are going to grow out of this technology base. So for more information on this, just monitor our website, kinoflo.com. And as more and more information is made available, we'll be posting this and keeping the world abreast of the further developments.
Okay, that's going to wrap up this video. I know it's a lot of information, but the Kino Flo Mimik is here to stay. It's going to be the industry standard, and I want you to know as much as I do about it. Make sure to subscribe, like, comment, all that stuff, and I'll see you in the next video.